This is problem number 5 from section 3.7. In this problem it says use implicit differentiation to find dy over dx and d squared y over dx squared using the following equation. So we're going to have to use implicit differentiation because we don't have an equation that is y as a function of x, right? This equation is not solved for y. So we're going to have to go through and use implicit differentiation to actually take the derivative. What that means is when we get to any term that is a y term, when we take that derivative, we have to make sure that we include dy over dx at the end. So let's start by taking the derivative straight away, left to right. Derivative of x squared, well, that's going to be 2x. Derivative of 4y squared is just plus 8y, but because I did the derivative of y, I need to put dy over dx behind it. Derivative of 9, well, that's just 0. So we have 2x plus 8y dy over dx equals 0. What we want to do now is solve for dy over dx. So we're going to subtract 2x on each side. And when we subtract 2x on each side, we get 8y dy over dx equals negative 2x. And now let's divide by 8y on each side. And that tells us our first derivative, dy over dx, is equal to, this cancels, right, negative 2x over 8y. So our first derivative, well, actually we could simplify this. This would be dy over dx equals, well, 2 over 8 is just going to be 4 on the bottom, so it's negative x over, that'd be 4y. So our derivative, first derivative, is negative x over 4y. So if we want to take a second derivative, we just need to take the derivative of this equation. Now we actually have something that is essentially derivative y as a function of x. So we're still going to use implicit differentiation because we have both x and y on the right side. But we can just write that the second derivative now, y over dx squared, is equal to the derivative of the right side. So what I needed to use is I need to use the quotient rule here. So I'm going to say that u is equal to negative x, u prime, v is equal to 4y, v prime. And so as we go through and we do this, we're going to take the derivative on the top of this negative x, that's just going to be negative 1. So then we take the derivative of 4y, and when we take the derivative of 4y, we're going to get 4 dy over dx because we're doing the derivative of y. And remember, the quotient rule is going to be u prime v minus v prime u all over v squared. So I'm going to go ahead and start with u prime v, which is negative 4y, because negative 1 times 4y, minus v prime, which is 4 dy over dx, times u, which is negative x, and this is all over v squared, which is 4y squared. So 4y squared. Now we can say that this is the second derivative is equal to, let's go ahead and combine these together. This will be negative 4y. When I multiply the negative x inside here, I get plus 4x dy over dx all over, this will be 4y squared, so that's going to be 16y squared. Now, I have dy over dx in this second derivative, but I already know dy over dx is negative x over 4y. So I can replace that here and say that this is d derivative, or second derivative with respect to x, is negative 4y plus 4x, and then I replace dy over dx, the first derivative, with negative x over 4y. So this is over now 16y squared. So we're going to go ahead and let's combine some stuff together. So we end up with second derivative of y with respect to x. This will be negative 4y plus, well actually it would be minus, we'll just put plus negative 4x squared for right now, over 4y, all over 16y squared. And then we can go ahead and say that this is, let's see, we can say that the second derivative of y with respect to x is going to equal well, let's say I multiply the top and the bottom. I'm going to do this. I'm going to multiply the top and the bottom by 4y. So when I multiply the top and the bottom by 4y, this is going to give you, on the bottom, let's see, 16 times 4, that'll be 40, that'll be 64y cubed on the bottom. And then on the top, this will give you, if I distribute that 4y to each term, that'll be negative 16y squared. And this will be, this will cancel, so it'll be minus 4x squared. 4y's cancel there, and obviously adding a negative is just subtracting. So then the last step would be, I can factor out a 4 on the top. Actually, I can factor out a negative 4 on the top if I want. Let's just factor out just the 4. Yeah, that'll be fine. We'll factor out a 4. That'll leave you with a negative 4y squared. And then minus x squared all over 64y cubed. And we can cancel the 4's, and that'll be the second derivative of y with respect to x. Cancel the 4's out, and we end up with just negative 4y squared minus x squared all over 16y cubed. So this is the second derivative. Now we did a lot of algebra to get there. This was the only calculus part. We did a lot of algebra to get to this piece. But technically, once we've done this, I mean, this second derivative is the same as this. It's just written nicely here.